Okay, so what I'm gonna do is I'm gonna show construction of an angle bisector and the proof that what we constructed is an actual angle bisector. So the first thing you want to do is you're gonna start off with some angle. This is the given angle, this green angle here, and what you need to do is construct the angle bisector of this angle. The way you do that is you just open up your compass to really any length. So let's say I open it up to that length from the vertex of the angle, this is the vertex, to some length, and it's just gonna be this length in this case, and you draw that first arc. So this is and mine is not gonna be perfect. I'm not using a compass, but yours will be a circle going from here to here where this will be equal to this. And then I'm gonna label these points now, A, B, and C, and it doesn't matter. That's just gonna help me with the proof. So you open up your compass to any length and you draw this first arc. Okay, you label where it intersects the two rays of your angle. And then what you do is you make sure that you open up your compass so that way the length of the compass is more than halfway. So you want it so from here, from A to where your compass hits is more than halfway to C, sort of, right? So it's just got to be like a decent sized arc. It could be the original arc, but whatever. This is going to be the one arc. So this is from A, this arc here. And I probably didn't do a good job, so I'm just going to do that again. So I'm going to pick some length. I'm going to actually try and keep it consistent. I'm going to use like something that's going to be somewhat accurate to what we're doing here. So let's see, what can I use? This should be okay. Okay. So let's say here, and then here. I'm just going to mark off a few points, try and make it as accurate as I can. Okay. And now you draw this arc, this orange arc. Okay, with center A. Then, with the same compass setting, you go to point C and you draw that same length arc. So it's going to look something like this. And then what you do is you call this point E, and the line from B through E is your angle bisector. Now, why is this? Well, we should see that basically the length from A to E is the same as the length from C to E by our construction. The length BE is congruent to itself, and then AB is congruent to BC, so we have that this triangle is the same as this triangle. These two triangles are congruent by side, 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 therefore angle 1 is going to be congruent to angle 2 by CPCTC. And then that guarantees that this ray, BE, is an angle bisector by definition. Now, what is that? Let's do that a little bit slower. Let's go through the idea again. So statements, reasons. 1, you're going to put down what you have by your construction. So we should see that BA is congruent to BC by our construction. Right, that's that first arc. This arc that I outline in pink now. It should be clear that that forces this length to be the same as this length. So these two are congruent. Then the next thing I did was I went from point A and I drew this arc going from A to here, right? And that's the distance from E to A. And I used that same compass setting to draw this arc from C to E over here. So then that forces this to be the same as this. And that's saying AE is congruent to CE. And this is by construction. Now, what you have here is you want to remember, what's your task? Angle bisector. You want to make an angle bisector of this angle. When is something an angle bisector? When it cuts the angle into two congruent angles. So at the end of the day, I want to show that 1 is the same as 2. That's your goal, because then that means that this line, BE, this line here, is indeed an angle bisector of the original angle. So I have these two facts by construction. The next thing that I'm going to say is that BE is congruent to itself by reflexive. Every segment is congruent to itself. Then the next thing that I have is that these two triangles are congruent. Which two triangles? These two triangles. This one here on the left is congruent to this one here on the right. Why is that true? Because of side, 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 right? We have BA congruent to the other one and so forth. We have these three sides, right? One side, BA, this side, congruent to BC. Then we have AE congruent to CE, and then we have BE congruent to itself. So I have that these two triangles are congruent. Triangle BAE is congruent to triangle BCE. And that's by side, side, side. 4. I'm going to change this color to something lighter. 4. Once I have that the two triangles are congruent, I know that then angle 1 must be congruent to angle 2 by CPCTC. Then after that, once I've shown that angle 1 is congruent to angle 2, that means that BE is the angle bisector of the original angle. So I should say, sorry, ray BE, right? Ray BE is angle bisector of angle CBA. And that's definition of angle bisector. Because I've shown that the two parts, the two angles that this ray broke up the original angle to are congruent. And that means that this is the angle bisector. This piece is the same as this one, then this is the angle bisector. And then that's it.